Hello everyone, let's discuss another concept, that is transformer core, laminations, and what is the shape of that core. So first we have to discuss laminated core. Practically, laminated core is used to reduce eddy current losses. We all know that. So these laminations must be electrically isolated using insulating materials. So if you clearly observe this image, so this is single sheet, that is single sheet of lamination. So these type of laminations which are tightly riveted, then only we are going to get that laminated core. So this is the whole combination of different sheet laminations which are tightly riveted, so which formed by thin laminations or thick laminations. So this insulation is used to avoid the flow of eddy currents from one lamination to another lamination. So we have to provide the insulation to that laminations. Why we have to provide the insulation? So in order to oppose or in order to stop the eddy currents from one lamination to another lamination. So eddy currents are restricted within the laminations. So this is the practical transformer. If you clearly observe that we have different number of laminations which are tightly riveted by using screws. So these are the n number of laminations which are tightly riveted in this picture, so that the area of cross section is reducing, which leads to increase the effective resistance. Obviously, if the effective resistance is increases, obviously what we have, the eddy currents which are present in this laminations which are very less. So like that we have to reduce the eddy currents. So by providing CRGO steel, we have to some extent decrease the eddy currents. So in order to decrease eddy currents further, we have to provide laminations for the transformer core. So for the laminations, this is the criteria to reduce the eddy current losses. So if you clearly observe here, this is the solid core. In this we have some circulating current. If the thickness of the lamination is decreases, obviously the eddy current losses are also decreases. Can write thickness of laminations is proportional to what? Eddy current loss. So if we clearly observe in the first picture, we have solid core. In this we have more amount of circulating current, but coming to second one we have thick laminations, but coming to first case we have some less amount of circulating current. But coming to last picture, this picture, we have thin laminations. In this, the amount of circulating currents which are present in that respective lamination only. So these are the insulating materials. Those are nothing but oxide paints, inorganic paints, and thin impregnated paper. So in laminated core, each lamination provides one parallel path. So the process of winding all the laminated sheets is called core staggering. That is, all the laminations are tightly riveted with screws. So if the laminated sheets are not tightly riveted, then air gap will be formed between laminated sheets. Then core offers high reluctance path. So if we have more amount of reluctance, obviously the amount of flux development is very less. The transformer draws more amount of excitation current to set up the flux, which is very undesirable. We all know that flux, which is equals to what? MMF by reluctance. So in this case, when the air gap between two laminations increases, obviously reluctance is also increases. If reluctance is more, obviously the flux development is very less. So in order to get the required flux, the amount of excitation current is required is very more. So in order to set up the required flux, the amount of excitation current is very more. The more amount of IE is required to set up the flux. So if the laminations are not staggered properly, huge sounds are formed, which are called humming sounds. So these sounds are formed because of magnetostriction phenomena. So what is magnetostriction phenomena? We have discussed this point earlier. So it is phenomenon of any material when there is a dimensional changes takes place whenever it is subjected to alternating nature of supply, which is nothing but whenever we have provided some magnetizing force, obviously there is a dimensional change in the magnetic domains. That phenomenon is called as magnetostriction phenomenon. So obviously because of this humming sounds, which is nothing but noise, the frequency of noise produced is double the frequency of supply frequency, double the frequency of supply frequency. Let us say supply frequency, let us say 50 hertz, right? Obviously noise frequency, what is the noise frequency? It is equals to double the supply frequency, which is equals to 100 hertz. So that's why transformer used in electronic circuits operate at very high frequency, which not audible frequency range. That's why we cannot hear noise from that electronic components. So these are the laminated core concept. Next we have to discuss the structure of the core. Then what is the shape of the core? The shape of cross section of the core may not be exactly square. It is made like stepped core, or other name is cruciform core. Let us take let us say this is A1. So cruciform core is nothing but, or stepped core is nothing but, so we have step like structure. So this is the structure of core. So coming to this square core, this is cruciform core. Let us say this is SC, this is CC. Then what are the basic differences and which one is preferred? Which one is preferred among this square core and cruciform core? So let us take, this is A1, right? Like that. This is another one, right? But the insulation required so like this we have to get the insulation. Let us say this is insulation. Okay, then what about diameter? From here to here we have diameter, right? Like that, or let us say this is like this up to this point. This is D2, this is D2. So coming to, this is what square core, this is cruciform core. So amount of our diameter of cruciform core is less than the diameter of square core. So the diameter of this structure is very less compared to this structure. So obviously the amount of insulation, that is D2 less than D1. Therefore the amount of insulation provided for, sorry, the insulation provided for cruci core should be less than the insulation provided for square core construction. So while placing windings, the length per turn is very less. So the amount of copper required for winding is less. Copper required for CC is very less. Copper required for square core is very more. Like that, we can say weight for cruciform core is very less compared to weight of square core. Like that, cost, yes, sorry, cost of scale. These are the differences between square type construction and cruciform construction. So because of this advantages, stepped core is preferred compared to square. Therefore stepped core, that is when compared to square core. So obviously the step type construction is very advantageous compared to square type construction. So if the steps are increased in stepped core, then it is more advantageous. If steps are increased stepped core, then it is more advantageous. So coming to practical transformer, so in practical transformer 24 to 48 steps are placed on core. To 48 steps are placed on core. This is about cruciform core type of structure compared to square type core structure. Thank you.